So my principal focus today is going to be to talk about some case studies and some of the impact of decision management and implementing decision management in enterprise, in the enterprise. And to do that, I've prepared a brief introduction first to the decision model, so you all understand you all understand the model and how it's implemented and what it does, so that you better understand the case study value statements. So I want to start by saying that decision management is not really an IT function. Now, we all know that IT is extremely adept today at building business systems and implementing business systems, whether they're off-the-shelf software or they're built from scratch. It really is a matter today of dial tone. I mean, it is expected of business of IT to be able to build those business systems very quickly and very accurately, and really they use multiple technologies, including business rule technologies, to achieve that goal. However, we think that the problem is really in the business. We think that the problems that remain in developing enterprise solutions remain discovering, defining, validating, and managing what amounts to what we call the business logic of the system. It's the policies of the business, the regulations the business has to comply with, and the operational decisions that are made within processes that the business really has struggles to express and to define and to clarify, and in a language, in a manner that can be consumed by IT, that IT can actually meaningfully implement, and respond with a system that does what the business wants it to do. It's one thing to be able to build a system or to implement a system. It's another thing to have that system really be responsive to the business user's requirements. And the problem lies still today in that business's ability to discover, define, validate, manage, and express those requirements in a means that the business can understand. That is the role of the decision model and decision management, is to be able to support the business in being able to express those policies, those regulations, those operational decisions. Now, not just express them in a rigorous and executable manner, a manner that is sufficiently rigorous that they can be implemented in an executable form. And so the role of decision management is all about doing that and doing it extremely well. And we at Sapiens Decision have developed a technology that we call Sapiens Decision, to enable business to do exactly that. And that's going to be the subject of my conversation today. Taking Sapiens Decision, implementing it in the enterprise, and what has been the net result of that from a functional perspective, but also from a financial perspective and from an operational perspective. So the traditional business rules approach we all know well, and we generate these rules. We understand a little bit about how to express rules today. We build rules, and what we're seeing is actually a sample of rules that were taken from a real project. This was an implementation of SAP, and these rules that were gathered as part of a catalog of about 80 plus rules that were gathered, all about how a bank may close an account. Upon an application to close an account, how the bank can assess whether that account can be closed. And these 80 rules took some 3 months to develop, but they suffered from all the problems of the business rule solution, expressing rules one at a time. And we all know what those problems are. Those problems are that you don't understand whether one rule has logic that is involved in that may be also used in another rule. We don't know whether the gaps exist between the rules. We don't know whether there are conflicts between the rules. It's very difficult to actually do that analysis, and it's even more difficult to test those rules and get them and ensure that they're accurate. And very often these rules are really only resolved and really only developed in reality after development in UAT. And so these rules become a lot of data, but they lack information because they don't have any structure in them. They don't really have structure that enables us to determine up front whether or not they're complete. And the problem persists and gets worse over time, because over time, when we have to maintain those systems and make changes to those rules, very often those changes are made without knowledge of the implication of those changes on a particular rule on many of the other rules that exist. And so we start developing over time additional gaps and additional conflicts and additional problems in the rules, and only by testing can we discover those. And very often in the tests we're unable to do the level of exhaustive testing necessary to ensure that those rules remain accurate. So the time it takes to develop those rules, the amount of effort it takes to actually test those rules after development, and of course fixing them after development is an extremely expensive process. And of course the operational problems and regulatory problems that persist when we do not have rules that are fully responsive to our needs and that we're able to test and exhaust all the possibilities. Now, the alternative is structure in our rules. And what we're looking at is those same 82 rules at a higher level, what it would look like in a decision model. You see in the decision model that we're able to, at a glance, understand the structure of the logic. We're able to, at a glance, see that the rules that determine account closure eligibility, and that's the decision, and you see the symbol for the decision at the top of this structure. We see that it points to the first rule family, that each of these blue structures are called rule families. They're a group of logic. And the first rule family, the decision rule family, the rule family that's connected directly to the decision, is the rule family that makes the final decision about whether this account is eligible for closure. We see that it is supported by three supporting rule families. One that's all about locks, whether there are locks to be taken into account. We see that there's a rule family that determines whether they're pending items, and we see there's a rule family that determines whether there are any linked products. Each of these rule families, or at least locks and linked products, are supported by, in turn, additional rule families that determine, in the case of locks, whether they're customer locks, whether they're account locks, whether they're card locks. In the case of linked products, again, they're orphaned e-products and orphaned e-bonds. So we see that the structure of the logic here enables us to understand that if we change the logic, any of these single structures, what the impact of that is, and we're able to also test this model very accurately. I'm going to actually take a different model. I'm going to take a model from the insurance domain to actually drill into the model and to explain to you how to read the logic within each of these rule families very quickly, just to show you the value of actually using the model in detail. So here is the decision model, all about policy renewal method. This model will determine whether or not an insurance company can renew a policy manually or automatically. This is an important decision for a particular insurance company that was suffering from very high cost of managing their policies, and they determined that one of the reasons that it was so high was because their policies were all being underwritten or renewed with manual underwriting, even though the company had technology to do automated underwriting. And so they developed this decision as part of their process, their renewal process, and the decision was all about determining whether a policy could be renewed automatically. I'm going to very quickly show you how to read the model to show how easy it is to create